Cocktail bubbly. And it's not because cocktails have alcohol in them. I just like that font. Good luck, man. Did you write both scores on there? Look at you. See you later. Yeah. So, all of you have already seen this, so this is a little anticlimactic. But, in order to graph a linear function, you can do one of four things. One, you could make a table of values, like we were in grade 5 or some crap, right? Barf. We're too smart for that, yeah? You could use x and y intercepts. That's not bad. We learned that this year. That's pretty good. You could use slope intercept form. Ooh, very sexy. We're in the 10th grade. We can do better math than you can. Right? As you draw out your slope intercept and you draw your Cartesian plane and you put on your y-intercept and you count very sultry like, ooh, I counted. Whoa. Ooh, I connected the line. Ooh. Right? We could do that. What's the problem with all of these? They require me to do more stuff with each one. Yeah? This one requires me to do all kinds of math. This one requires me to do all kinds of algebra. And this one requires me to do it right. I need a slope intercept. My b has to be, not has to be, but my b should be I don't want to say whole number, should be an integer, right? Because if our y-intercept is a fraction, then it's a bit of a pain in the ass, right? Because then we got to change scales, and is there room enough to change the x scale and the y scale, and blah, 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 blah. That's a big pain, right? Okay. Well, there is a fourth way to do it, and that will soon become your best friend. It is called point-slope form. Some teachers, of course, because we already have slope-intercept form, like to call this slope point form. But I don't know why. For me, point-slope sounds better. I don't know why. So I call it point-slope form, even though the other one's called slope-intercept form. The other one could be called intercept-slope form, but that would sound bad, right? It's just my own ears. I like the sound of point-slope form. I don't know why. You can call it slope point form if you wish. Aight? Aight. Now, all of you should have seen this in the past. It looks like this. And we have seen all of those things before, haven't we? We have seen this. That should have been a highlighter. We have seen this in our slope formula. And we have seen this frickin' everywhere, right? M is slope. Now, the thing that's nice about this is this point right here is a known point on the graph. So we can start there to count for slope. This point right here is where we start. Instead of the y-intercept, we start at that point. But it's a little snaky. All of you have seen this before, but I just want to remind you. Y minus 3 equals 2x minus 4. Now, these are our starting points, right? But we have to remember, because there's a negative sign there, it's not that starting point, it's the opposite. Here is what I mean by that. If you don't pay attention to me and all you heard from me and your teacher the first time you saw this was, these are the points on the graph, then you would say, okay, my graph must start at -4, -3, right? Can you all see yourselves making that mistake if you didn't listen? Yes. But you're smart kids, and you know that this has to be opposite. And here is why. For this to work, this side, the left side, must equal the right side, right? So, if I use -4 and -3, which is what kids always use because they don't actually pay attention, if I did that, then if I use -4 and -3, that's an x value, isn't it? Right? So where should it go? Right there, correct? That's a y value, right? So where should it go? Right there, correct? What is -3 minus 3? No. -6. What is -4 minus 4? -8. What is -8 times 2? Redeem yourself, Kush. What is -8 times 2? Yeah! Way to come back. Good job. Now, does -6 equal -16 in any universe you people live in? We're getting to that. Does this work? No. What would happen if I used the opposites? What if I used 4 and 3? Then, what is 4 minus 4? 0. What is 0 times 2? 0. What is 3 minus 3? 0. Does 0 equal 0? Yes. That's why you have to use the opposites. Everybody cool? Yeah? Okay. So, here is point slope form. I want to know the attributes of that line. Attributes mean anything you can tell me about that line. For example, some of my attributes are stunningly handsome, really funny, incredibly intelligent, and things like that. Some of your attributes are almost as incredibly intelligent, almost as stunningly handsome or pretty, and almost as uproariously funny. But not quite. After you've lived another 30 years, you may get to uproariously funny, stunningly handsome, and what was the other one? Incredibly intelligent? I can't remember what the adjective was. But for now, you're almost there. You'll get there soon, though. Have faith. It just requires, living a little. So what are the attributes of this line? What can you tell me about this line from just looking at it? That fraction is in what spot? Which is where the m is, right? So what is m? So this line has a slope of -2/3, yes? And do I know anything else about this line just from looking at it? Yes, I do. I know the point, one of the points on the line. What is it? What is it? 1, -2. Because I got to use the opposites or it won't be equal, right? When x is 1, 1 minus 1 is 0. When y is negative 2 plus 2 is 0. 0 equals 0. That's what we want. Everybody understand? Okay, so what is the second one? What's my slope? Negative 1/4. What is my known point? Negative 3 and positive 4. Now, we're going to stop there for a second. If I wanted to graph number 1, where would I go to graph it? I would go to 1, negative 2. But 1 point is not a line. I need a second line, yes? How would I get to the next point? What are my two options? I could go, you know my slope. How do I get to the next point on that line? I could go down 2 and right 3, or I'll change shades of blue, or up 2 and left 3. Everybody good? Okay. What if I was doing graphing number 2? Where would I start? Negative 3, 4, and then what would I do? Down 1 and right 4, or, and I'll change shades of red to go to a different pink, or up 1 and left 4. Everybody understand? Okay, so let's do 3. What are the attributes of the line? It's tricky. Why is it tricky? It looks like it doesn't have a slope, doesn't it? But it's 1, isn't it? Because if I put brackets right there and multiply it by 1, isn't it just x plus 2? Okay, so what is my starting point? My slope equals 1, and my starting point, negative 1. Don't x's go first? Negative 2, then negative 1. Everybody good? Do I need to remind you how to graph it, or are we good? We'll do the second one and make sure. What's this guy's slope? 1/2. And what's the starting point? Negative 4 and 0. Because if y is 0, right? Are we okay still? Could we graph these two? Okay. What about 5? Slope equals negative 1, and starting point? Negative 5, negative 3. And the last one, back to the beginning. Slope is 4/5 and 1/10. Easy peasy lemon squeezy, right? No problemo. Prove it. What's my starting point here? Negative 1, 2. Negative 1, 2. What's my slope? So what do I need to do? Up 2 and right 1, 2, 3. Or, I think I went right 4 there. 1, 2, 3. Or Down 2 and left 3. Doesn't get much easier, does it? Now please notice that this is not a very good candidate for slope-intercept form, is it? Because look at the y-intercept. It's right in the middle, isn't it? Barf. Everybody cool? All right. I'm going to leave it this zoomed in because it makes graphing easier. What's my next one? What's my starting point? So I go over to here. Negative 1, 2, 3, 4, 5, negative 1. And what's my slope? Negative 2. So what are my options? Up. Up how far? 2, 1, 2, and left 1. Or down 2 and right 1. Right? This one is tricky. Read that sentence or those instructions and tell me what is important in there. There's 2 lines. So I'm going to have line 1 and line 2. Excellent. What else is important? The equation. Now, is that equation one that we like to work with? No. So line 1, we know, is 2x minus y plus 8 equals 0. How can we make that something we like? Isolate y, which means what would have to happen? Just move the y. Doesn't y equal 2x plus 8? Does, doesn't it? Okay, so could I graph that right now? I could, couldn't I? Where would I go? Positive 8. 1, 2, 3, 4, 5, 6, 7, 8. And I would have a slope of what? 2. Which would be what? Up 2 and right 1. But that goes off the graph. So I should go where? Down 2, left 1, down 2, left 1, down 2, left 1. There is my line. Correct? Okay. What does the third sentence tell me about line 2? Or sorry, the first sentence tell me about line 2. They're perpendicular. So what does that mean? So I know that line 2 must be y equals negative 1/2 x, right? What else do I know? Where do they cross? They cross at 8, right? So, what's this guy's b here? 8. What's another way I could have done it? Well, I know that this is the starting point, right? So could I have gone down 1 and right 2 to get a slope of negative 1/2? Could I have done that? So I know my line 2 would go right there, yes? Do I know that point? That point is 2, 6, right? So could I have written y minus 6 equals negative 1/2 x minus 2? Could I have gone up 1 and over 2 and done the same thing? Yeah. Everybody understand? You can see that point slope and slope intercept can work together. Why can they work together? They're made up of the same stuff, aren't they? X's, Y's, and slopes. Right? Okay. It is 11:45-ish. Last till 12:15. You got half an hour to work on page 142 and 143 and 144. Remember, must you do them all? Probably not. But you should have noticed by now that often these assignments get harder as you go further along, yes? So, just because you understand number 4 with X's and Y's, does that automatically mean you're going to know how to do number 23 when you're not talking about X's and Y's, you're talking about hockey tickets and people at the game? Everybody understand? Please notice, for example, number 10 right here. Is that X's and Y's? No, it's IVs and DVs. But IVs are what? Where do we measure IVs? On the x-axis. Where do we measure DVs? On the y-axis. So even though it's not X and Y, it really is what? Right. The question doesn't say X and Y anywhere, but we know that whatever this DV and IV are, there's your X and your Y, right? Look at number 16. No X and Y, but there's IV and DV, right? Number 17. No X and Y, but IV and DV. Number 18, no X and Y, but IV and DV. This is what I was talking with Harvey about earlier. Given enough bananas, I can teach a monkey to do point slope form, right? Because it's X and Y. That's not the real world, though. The real world doesn't have X's and Y's, does it? Right? If you got to figure out how much money you can spend on pop and chips after you've paid for your rent and your car insurance and your gas and everything, is that X's and Y's? No, it's independent variables and dependent variables. So the real challenge in math is taking that easy X and Y thing and applying it to real life, right? But the only thing you need to know to apply it to real life is that whatever your IV is X, and whatever your DV is Y. And then you can take that X and Y knowledge that's super easy, right? You just put it on a graph and put it in real life. Everybody good? Go. You got half an hour.